Hello and welcome back. Our guest is Dr. Sam Shea, a world-renowned expert on genetics and how genetics set you up for different diseases. And I'm going to read his bio for you here. Dr. Sam Shea helps busy, health-conscious entrepreneurs and mompreneurs, I like that word, mompreneurs, increase their energy, resilience, and stop the clock from the effects of aging so they can create and sustain a healthy and free life. Dr. Shea has dedicated his life to helping others through functional medicine and functional genetics. He has recently authored a new ebook on genetics where you can learn the different types of genetics-based weight gain, how to future-proof your brain, food triggers, how to genetically determine your optimal carb tolerance, vitamin D absorption, and immunity support. Dr. Shea has offered a free copy of his ebook, Your Missing Genes, the revolutionary method to find your ideal diet, balanced weight, and help stop the clock of the effects of aging. And you can get that at drsamshea.com/genetics. So after this interview, just go over to Dr. Sam Shea, SHAY.com/genetics, and you can pick up a book that will summarize so much of what you need to know. So Dr. Shea, welcome.
Thanks, Tom. Thank you. Do I call you Tom, Dr. Brian? Do I,
sure.
Dr. Tom? Sure. Okay. Hey, you works for me, so you can just say that. I'll respond. Okay, sounds good.
Good. So, I think most of our attendees have heard some concepts about genetics and have moved past. Historically, we thought if you've got the gene, you've got the problem. We've had movie stars who have done radical surgeries because they have the gene for breast cancer. And without any indicators of a problem. And I think most today understand that the majority of diseases are not, if you carry the gene, it doesn't mean you're getting the disease.
Correct.
It means that you're vulnerable to getting the disease.
Correct.
And my analogy for that is if you pull at a chain, it always breaks at the weakest link. It's at one end, the middle, the other end, your heart, your brain, your liver, your kidney. Well, your genetics and how you live your life sets up which links are weaker. But the takeaway we all want is don't pull on the chain so hard. And as we were talking before the recording started about this current pandemic that we're in and the protocols that we mutually agree are critical, our lifestyle and how we live our lives, which make us vulnerable to falling prey to a severe response to an exposure or having a strong immune system that suppresses any acute response to the exposure. That's all lifestyle. So from that perspective, what are some of the indicators a person can use to determine if they need to spend their hard-earned money on getting genetic tests?
Sure. So there's a couple key big picture concepts to hold when making that decision tree of where to put one's time, attention, and resources. So piggybacking off of what you said about one gene, one disease theory, that's really inertia from from germ theory. One germ causes one disease, as opposed to looking at the milieu, looking at the terrain, looking at all the factors that make one vulnerable to be infected from a particular pathogen. And genetics is very similar. It's like you may have the vulnerability, but it's the terrain, it's your lifestyle, it's everything else that sets you up for the expression. If you're looking at how to know, there's a couple key things that come to mind. Number one, has everything else failed in terms of have you tried all these different, jump from one protocol to one product line to one practitioner to another, and you haven't yet done genetic testing? Now, for me personally, I like running both functional and genetic testing at the same time when I work with people. And people may ask, well, why would you run both? Well, they check for different things. Genetics will tell you the window of vulnerability of how you got to where you are, as well as provide a very clear window going forward of what you need to do to future-proof from further expression, as well as to look at the lifestyle you can do to reverse significant portions of current expression. But genetics testing will not tell you what your cortisol levels are now, what infections you have in your gut now, what your B12 levels are now, what your vitamin D status is now. They will tell you, though, your capacity, how you're able to work with these things, but they don't tell you the exact levels at the moment. That's why I like to do both at the same time. So if you have something you've been struggling with that has not been answered, then you can look to genetics. If you have a lot of inherited disease weirdness in your family, it's really good to look at genetics, because you'll be able to get a window into what are the clusters of genes to look at, as opposed to chasing an individual gene as if it's some magic bullet. Now, for me, in my family, I've got, within 2 generations, I've got cancer, heart disease, stroke, neurodegenerative disease, but no diabetes. I win. I've got very meaningful genetic issues in my immediate family line. And when I looked at my genes, it made total sense, because the 15 major inflammatory genes were not very good variants, shall we say?
Mhm.
And
So with that example,
Mhm.
for one person in your family, it manifested as cancer.
Correct.
For someone else in the family, it manifested as strokes.
Correct.
But the common link is the response to environmental triggers may give you an excessive inflammatory response. And is that one of the takeaways from your family example?
It's I'll even take it just a couple steps up and incorporate exactly what you said. So that's going back to the whole idea of germ theory now is gene theory, and that's not entirely accurate. What I'm looking at is not the disease genes. I'm not looking at the genes for cancer, heart disease, stroke, diabetes, or Alzheimer's. I'm looking instead at the meta genes above them that are the major directors of all disease processes. So the 7 major directors of all diseases in the genes are inflammation, free radical quenching, liver detoxification, vitamin D utilization, methylation, cardiovascular integrity with blood pressure, and fat and energy metabolism. 7 drivers. So when I'm looking at genetics, I'm not chasing after the heart disease gene, the diabetes gene, the Alzheimer's gene, the stroke gene,
Right.
etc. I'm looking instead at, is there a problem with inflammation as such? Not an individual inflammatory gene. Everyone wants to jump on interleukin 6 or TNF alpha, which is not a bad place to look, not at all. But I'm looking at the entire cluster of genes in that inflammatory pathway, the major ones. A lot of people will jump to MTHFR, which has gotten a lot of, in my opinion, unnecessary fanfare, not because it's not important, but because it's like a germ theory idea. MTHFR has a bunch of other genes that surround it. MTHFR, and there's MTHFR2, the sequel. And there's MTRR. There's even downstream, you can even go as far as the GSTP1 in the liver, which is the final stage for converting it down the sulfation pathway into glutathione. Like, you can get super nerdy, super nerdy on the genetics. But the point being is that there's over a dozen major genes with methylation. But even more important than that, the inflammatory genes have direct oversight control over methylation. So if your inflammation is off, it's going to affect your methylation. Now, this is all, Scrabble speak, all these big words to basically say, let's look at your inflammatory pathways instead of fixating on a singular disease gene. Let's look at your ability to quench free radicals and all the environmental inputs that go into that. Because if you're in a stressful environment of whatever that means, toxic stresses, emotional stresses, physical, infectious, etc., you're going to have your genetic pathway, if you have enough vulnerabilities like my family does, suddenly inflammation goes amok, free radicals go amok, liver detoxification shuts down, vitamin D utilization goes down, and then downstream from that, the quote unquote disease genes express.
Let's take the example that you've given about inflammation as one of the higher levels of evaluating genetics.
Right.
As opposed to a single gene. Now, I read one paper that said there's about 1,200 genes that are associated with inflammation in the body.
Yeah, I'm
So
looking at the upstream ones, the
big
that are
ones.
the ones that are upstream. I can even show you an example of them and show you how I look at them.
That's all right. No, that's all right. It'll be too geeky for people. They'll go out to left field.
Okay.
I think. But my question is, okay, so my family has these genes of inflammation. What do I do with that?
Okay.
What's the value of recognizing that, where one family member has a stroke, one has cancer, so different diseases, but common pathways that cause the bomb fire? What do we do with that? Is the message that let's look and see where inflammation is manifesting in your body?
Yeah, so there's several approaches. First and foremost, you do a detailed lifestyle analysis covering all the different areas of someone's life. I have a particular model called the 10 Pillars of Health. I have another free ebook on my website called Biohack Your Biohacking, which goes over all those 10 pillars in detail. I'll just super brief. First one is brain and hormones. Second is bowel and digestion. Third is body, physical damage, untreated injuries, bad dental work, the physical body. Fourth is burst exercise and movement. Fifth is biotoxins and other toxic exposures. Sixth is bionutrients and nutrition. Seventh is breakfast and routines. Eighth is bothers and stressors. 9 is bugs and hidden infections. And 10 is bedtime or sleep. So brain, bowel, body, burst, biotoxins, bionutrients, breakfast, bothers, bugs, bedtime. 10 alliterative pillars of health. When you analyze all the 10 pillars, you can assess where in the lifestyle things gone wrong that may be triggering inflammation. That's at the just general lifestyle assessment. The other thing to do with the genetics data is that if you have clusters of genes related to inflammation, so like the example I was going to show was showing a client of mine that had of the 15 major pro-inflammatory genes, they can be split up into 3 separate subdivisions, not just inflammation, but initiation of inflammation, propagation or continuation of inflammation, and extinguishing inflammation. And the most important ones are actually the extinguishing. If you have a small fire that's smoldering, if you have no way to put it out, it's going to cause a problem, whether it's big or small. But it's the interleukin 10 specifically. And those are really, really important. So if you have clusters of genes that are all connected together, in this case, the inflammatory pathway, what you can do is then it's the style of analysis that I do, is that I look at all these different genes, look at them in clusters, and then identify what has been done in the peer-reviewed scientific literature done on humans to change the epigenetic expression of these genes for the better. And then I look at what is the fewest number of lifestyle interventions that can be done that help the most number of these high priority genes. The problem people have when they go to 23andMe or Ancestry, they get whatever, 300 genes, 600, the number keeps changing. And then they're like, here's your list of 300 health tips that aren't prioritized and are super overwhelming. How about instead, here is the most important, fewest number of lifestyle changes customized to your specific genetic dice roll that are going to help the most important, highest priority number of genes. And just bring it down to like, here's the 10 most important things to do for life. Mm-hmm. And then when you're done with those 10, here's the next 10. And then the next 10, and pretty much stop there. And then we're done. Like just keep it to prioritize fewest number to help the most number of high priority genes. That's how to use the information.
And that's brilliant. And how do you know if what you're doing is working?
Oh, well, 2 ways. One is the changes in the subjective experience of the client, whether they're losing weight, less brain fog, they're not getting sick as often, they're sleeping better, their mood is better, their gut's better, their energy is more sustained, etc. The other is you look at the functional labs. The genes don't change over time. I mean, unless you're dumb enough to inject CRISPR into your bicep or something, like you just, the genes aren't going to change. So what you do is you do functional testing to measure where you're at in this moment of time. So whether it's like you run the ion panel, was one of my favorite labs to run like ever. And if people want to be super nerdy about that, I've got 2 videos on my YouTube channel on the ion panel. You can check adrenals, you can check the basic blood profiles, you can check gut testing. That's your bread and butter. Oh, sorry, gluten-free bread and butter. Pardon me. And thyroid. You use all the different functional labs that are the most appropriate to your unique situation to monitor progress, as well as dial in more specific nutrients and lifestyle changes specific to the markers that you have. Genetics does not test for every nutrient or every lifestyle change you need to do, because the genetics research is, I mean, labs vary. There's thousands of papers published every year. I like to do them both, because both functional and genetics, because they both synergize with each other.
So if someone has a crazy family health history, many different things, which you suggest may be one of the areas to validate, I should look at the genetics that I've inherited because of the difference of diseases that are in the family. And it comes back and it says, oh yeah, inflammation's a big deal for you, that you're vulnerable. You have the genetic structure to not being able to put out a fire very well, if that's the latter third of the inflammatory genes that you may individually have
challenges on, variants.
A variance to. Then you're suggesting there are certain functional tests to do to say, what's your current status with inflammation, or what's your current status in terms, and then you evaluate diet, you evaluate some blood draws of vitamin D level, because vitamin D is anti-inflammatory, or whatever.
Homocysteine, lipid peroxides, high sensitive C-reactive protein. I mean, we can list the buffet of metabolites and nerd out.
My father died from sudden massive coronary at 64, and he had no cardiovascular risk factors. And it turned out it was an elevated homocysteine that no one had ever checked.
Yeah.
This was 1990 when that occurred. So that's an example where if I carry the genes to not being able to put a fire out very well, and if I also carry the gene to not use folates very well, or B12 very well, so my homocysteine has a tendency to go up, and I'm not putting out fires very well, that I carry those genes, then I would be one of those at higher risk of, and homocysteine is called the silent killer. So I'm one of those that would be at higher risk, not because I have exceptionally high homocysteine right now, but I may just have borderline high, maybe a little bit too high. But if I can't put the fire out, it could take me down.
Correct.
Is what you're saying. Well, that makes a lot of sense, that if you are carrying a family history of multiple different diseases, that may validate that, I need to look at this bigger picture of the higher level genetic markers that I have. Not the one bug, one gene, or one bug, one disease, or one gene, one disease, but the clusters of genes for the different categories. That makes a lot of sense.
I call that functional genetics, like functional medicine. So we're looking fundamentally at the complexity of gene interplay, as opposed to chasing a singular one. And I'm sorry to hear about your father. I mean, my grandfather died on the operating table in 1965, and he was the founding director of the Fels Cancer Research Center at Temple. And he published 300 articles in Science, and I never got to meet him because they misdiagnosed They thought his angina was caused by a quote unquote reflex arc by an inflamed gallbladder. And so they took out his gallbladder, but he died on the table from a coronary. And the coroner told my father, who's the beginnings of his medical career, that there's so much plaquing in the coronary artery, you couldn't fit a pin through the coronary artery.
Wow.
And it's, coronary artery disease and cardiovascular issues are rampant in my family history. And what was not ever discussed back in the 40s, 50s, 60s, et cetera, was, looking at inflammation from the standpoint of nutrition, exercise, et cetera, except maybe in a couple odd places here and there. And I am acutely interested in what can be done from a prevention standpoint, because I really hit the genetic lottery of bad luck in terms of vulnerable health issues. Why I got into this game, Tom, because I was so unwell as a child from 6 to 18, but there was kind of this diffuse, non-diagnosable, and I didn't understand why I was so unwell while everyone else was fine, in my class, whatever. And it's because I had such, to be technical, crappy genes from a health standpoint. And it's been a very long road to figure out genetics, functional testing, lifestyle, et cetera. And what I also would want to share with people listening to this, the genetics is not also only reserved really for people who are concerned about their family, what they've inherited, or they're dealing with something chronic and unfortunate right now. It's also a lot of fun, fun is not really the right word, but it's really helpful for people who are biohackers and life extension enthusiasts, because the real, there's lifespan and there's health span. And there's people who are into these really big life extension, biohacky, human longevity circles. And it would be really, really important for them to know. They may feel great, drinking bulletproof coffee at 30 and 40, but if they don't know their genetics, they may not be doing the things they should be doing for the next 50, 60, or if you're planning to live to 180, like a mutual friend of ours, for the next 150 years. There's genetics would be incredibly important. And of course, getting, your annual functional testing panels, like your annual ion, for example, like your annual metabolic check, things like that. So genetics is useful for so many people in so many ways. And one of the last bits that I think most people don't really key in on is finding their genetically ideal diet, especially around carbohydrate tolerance. And now there's a three-dimensionality to genetics that almost no one talks about. It's not about variance, like the red, yellow dot system, where you got one good copy from mom, one good copy from dad, or one bad, one good, or two bad. That's the red, yellow dot system we normally see on these 23andMe tests, et cetera. I'm talking about copy numbers. Copy numbers is a whole three-dimensionality to genetics no one knows about. So what it means is the number of duplicates of the gene, not simply the variance of it. It's the duplicates. And specifically, I'm talking about the AMY1 gene, which is the gene that secretes amylase in the mouth to break down carbohydrates. The variance of that gene really doesn't affect the amount of amylase that it's secreted. It's the number of duplicates of the gene. So if I have one copy, I secrete 1x of amylase to break down carbs. If I have 20 copies, I do 20x, which is huge implications for my diet. So from a personal example, I had been teaching, nutrition, nationally, internationally for a while, and I was still having digestive issues. So I felt odd being on stage and still having these digestive problems. And I had the most Portlandia diet ever. I knew the names of my farmers. I knew the names of the animals. I petted the cow, fed the cow, etc. All these things. And I was still having terrible, embarrassing digestive problems. And then I finally did my genetics profile on my carb tolerance. And it turned out I had the copy number of the amylase gene, a copy number of a 2, which is similar to the Inuit. So it wasn't a quality thing, because the sprouted organic soaked quinoa I was having was handpicked by left-handed monks on a full moon off the South Island of New Zealand, blah, blah, blah.
Right.
It wasn't a quality issue, it was a quantity issue. Quantity. So what was it? Napoleon says quantity has a quality all of its own. When he's referring to like 30,000 troops a week he was burning through. So I have, and within 1 week of reducing the carbs to my genetic tolerance, my digestive problems of 20 years vanished. So you want to talk
a
about
really great example. That is a great example of the value of doing this deeper dive in genetics. And you do it once, because once you've done it, that's what you've got the rest of your life.
Correct. It's the best amortized testing you could ever do. You can amortize the investment over however many decades you want to live. Is the cheapest test you could possibly do.
That's a very good point, And then from there, you do the biomarkers, the functional tests, to see how that particular genetic setup is manifesting right now. So in the example that you just gave, you might look at your insulin sensitivity, you might do a HOMA score, glucose and an insulin, and plug it into the formula to look at your insulin utilization.
Insulin, just real quick. So the lower the copy number, this is also another research paper, the lower totally matches my experience as a low copy number person. The lower the copy number, the faster the spike and fiercer the spike of insulin. Whereas the higher the copy number, the slower and more level. Now, this makes perfect sense anthropologically and evolutionarily. If I'm a hunter-gatherer, which my genetic stock comes from the northern latitudes of Russia, which makes there's not a lot of carbs up there. So what happens is that if you're a hunter-gatherer, there's not a lot of carbs. Fruit, couple times a year, couple weeks a year, that's it. Maybe a honeycomb if you're lucky. So you've got a very short window to stuff yourself stupid from what's on that apple tree or berry bush before the bears, bees, deer, insects, rot, mold, rain, and other tribespeople of your own tribe or of rival tribes eat or get to those berries first. So of course you should have a raging quick insulin response to suck in as many calories as possible, because that could be like 2 weeks worth of calories right there, which is about 5% of your annual caloric needs, which is a huge payoff.
Yeah.
And if you have, that's why your insulin spikes so high, the lower your copy numbers are based on evolution. Whereas if you have higher copy numbers, if you came from an area of the world where you had agriculture that went back a long way, and there was this genetic pressure for the copy numbers you had more sustained carbs over longer periods of time, year after year after year after year. So the spiking insulin was actually not a great idea, and the higher copy numbers were, so they became yoked. So even with the copy numbers, you get a tremendous insight into your insulin sensitivity. Also your exercise, the lower your copy numbers, the better suited you are for sprinting versus more long distance moderate exercise, the higher copy numbers you are. Because if you're a hunter-gatherer, you can be sprinting after calories versus walking around growing stuff.
That's brilliant. That's really brilliant. And it's exciting. It's really geeky. And I think some people, some people didn't have to follow that, but you and I could go down that rabbit hole for an hour or two talking about it. But what it tells us, and what's been really valuable here for me, one of the things really valuable today is this concept that to get past the one gene, one disease, and to go to a higher tier, a higher level of looking at genetics for packages of genetics. And as you've described, the 10 different packages that you look for. Pillars. And then from the pillars. And then from there, check it out to see how is that manifesting right now. And that's where the functional testing might come in.
Absolutely.
So for everyone out there, go to Dr. Sam Shea, SHAY, DRSAMSHAY /genetics. Take a look at his book, download it, it's free, his ebook. Get more information on this topic and see how this might just relate to you. And then you might choose to allocate some of your resources to get this type of genetic test done. It might be a really smart move. It might save your life. Bottom line, if I had this, not to be hyperbolic, but if I could have some magic time machine and go back to the time of my grandfather, 15 years before this coronary issue, and I had run the exact same tests that I run today, I could have prevented that entire thing from happening. Yeah. Same for me. If they had just checked a homocysteine level, that's all it took. Well, Dr. Sam Shea, thank you so very much for being with us. I know there's a lot of great information here and people know where to go to learn more. We very much appreciate your time and your knowledge.
Thank you so much for having me. I've enjoyed chatting with you. We can nerd out later.